Hi guys, welcome back to my YouTube channel. If this is your first time, do not forget to subscribe. Also give a thumbs up to this video if you've enjoyed the video. Alright, so in this tutorial we'll be looking at the 0x02.c, that is C functions and nested loops. Alright, so once again I would stress the importance of having to go through the resources provided. It's very important that you check all of the resources before completing your project. Very important. This video is actually very nice. When you watch the video, you can stop the video at 14 minutes. Also, it's important that you look at the C header file and also the purpose of function prototype, because we'll be using a function prototype to complete this task. Alright, so let's come to our requirements as we will normally do. The allowed editor is VI and GCC compiler, but we will not be compiling any code in this lecture. Okay, all your files should end with a new line. Now you need to create a readme file as we normally do. The codes will be checked using the Betty style, both Betty style and Betty documentation. Also, you're not allowed to use global variables and no more than 5 functions per file. You're not allowed to use the standard library. Any use of the functions like printf, puts, etc. is forbidden, except otherwise stated. You're allowed to use _put char, and you don't have to push _put char.c. We'll use our file. If you do, we'll be taken into account. In the following example, the main.c files are shown as example. You can use them to test your functions, but blah blah blah. Okay. Now here's the most important part of the requirements. The prototypes of your function and prototype of the function _put char should be included in your header file called main.h. So first off, we need to create a header file called main.h. Okay, so to begin, I'll launch my sandbox. Okay, so when I launch my sandbox, okay, I am now in sandbox. As usual, change my directory to root. Now the first thing I need to do is to navigate to this directory. Okay, now I have created this directory, but if you've not created the directory, you need to first of all change your directory to this. Let me show you quickly. So you already have this directory created a long time ago. Okay, so if you change your directory to this directory, then the next thing you need to do is to now make this directory. So using the function make directory. Okay, so it's not going to create because it tells me that the directory already exists. Okay, so since my directory already exists, the next thing I do is just navigate into the directory. The next thing I need to create now is to create my readme file. Okay, so you can echo into your readme file. Let's say echo, I can say nested loops, and then put that into a readme.md. Okay, so if I hit enter, a readme.md file will be created, but I already have my readme.md, and this is the content I have. My readme file says my nested loop and functions. That's what I have for my own readme file. So you can choose to put whatever content you want in your own readme file. Okay, so after creating the readme file, the next thing we need to create is we need to create the header file. So I already have the header file created, so I'm just going to display, I'm going to use VI to show you what is in my header file. Okay, now for my header file, all you need to do is, now these comments are entirely non-necessary. They are just descriptions to help you understand what is happening here. Now I can as well take out the comments, and I can as well take out this this syntaxes here, and nothing will happen. Okay, so what should be contained in your header file? Now for your header file, we're told that the prototypes of all your functions and the prototype of the function _put char should be included in your header file. Okay, so how do we get to the prototypes? First, let me open this put char so as to show you what the content of put char looks like. Okay, so this is the content of the put char _put char file that was mentioned in the project. So the prototype that we need is from the int down to char c. Okay, so I'm going to copy that out and I'm going to paste it into my main .h file. But take note that I have taken out the c and left only char in it. So this is just going to tell me that if I want to call the underscore put char function, it's supposed to take an argument, which is a form of a character or a string. For the second one, so how do I get the rest? I already have for the underscore put char. Now how do I discover that for the rest? It's provided for you in your project. So when you go to task 1, for example, you see for task 1 we have the prototype given here as void print underscore alphabet in void. For task 2 you have a prototype given here as void print underscore alphabet underscore x10 void. For your project 3 you have your prototype. So just copy all of the prototypes provided for you throughout the entire task, and while you copy, as you copy each one of them, all you need to do is just come into your main.h file and paste them all. So after doing all of that, as usual, you exit your header file and that is sorted out. Now the second thing you need to note is you can choose to write a program that prints underscore put char. You can choose to write a C file named underscore put char.c, but we're told that it's not necessary. You don't have to push it. Even if you push it, it will be taken into account. So best you just have your main.h file. But if you want to, all you need to do is just come here and type exactly what you have in the underscore put char.c file and save it as your own underscore put char file. For example, I have mine. So if I display it, I've typed exactly what I have here into my underscore put char file, as you can see. Okay, so good. At this point we can now start working on the project. Do not forget that at this point in time you can git add, git commit and git push so that your header file becomes pushed to your GitHub account. Now the next thing we want to do is we want to create a file that is going to print out underscore put char. That is going to print underscore put char followed by a new line. Alright, so I will just display that since I already have it. Now remember that the header file we're going to include here will be the main.h. Why is that the case? Alright, we were told here from here that okay, just like you see mentioned here that says do not forget to push your header file main.h. So all of the prototypes that we have written inside this header file main.h allows us to be able to use all of the functions that we want to use. Also the underscore put char is also a dependent of the header file. So if you do not have the header file, all of your codes will not run and the checker will continue to fail. So I would include my main.h instead of including the standard io.h. But this time around we will be including the main.h. Now take note that the main.h is in quotations, which tells us that it's not a standard library, it's a header file that we created. Alright, I have my comments accordingly. Now the first comment here that says main tells us what the main here serves as the name of the function. So the main here serves as the name of the function, and the argument to be taken by the main is blank, is void. So no argument is supposed to be supplied into this function. Now you need to tell us what the function will return. That is the second statement here that says return always 0, and that indicates that it's successful. So I start by writing my int main, and I have my underscore put char underscore put char. Now you see that I'm expected to print out underscore put char followed by a new line. So based on the underscore put char syntax, underscore put char file, C file that was already created initially, the file would only write the arguments provided. So I have provided the argument underscore, is going to write it for me. I've also provided the argument p the argument u. So it's going to put all of these words together to spell underscore put char, and the new line that I was told that my code should end should be followed by a new line. So return 0, and then the function is complete. So I can then save the file accordingly. We normally do so with :wq, and after saving this file, just git add, git commit, and git push. Do not compile this file that you just created. Do not compile it. There is no need to compile it. Even if you attempt to compile it, it's going to bring back an error. So at this point, all you need to do is just git add, git commit, and git push, and then you can come forward and check your code. If you also want to be sure that you've written it correctly, all you need to do is Betty check your code. Just type Betty, the name of the file, putchar 0-putchar.c, and allow Betty run some checks. If Betty brings back no error, then it means your file is good to go. Now for the second, for the task 1, we're told to write a function that prints the alphabets in lower cases followed by a new line. Alright, so how do we go ahead to solving this task? It's not very difficult. We already have the prototype copied inside our main.h file. This is actually the name of the file. So what we need to do is just come here and say vi and the name of the file. Okay, so once again we include our main.h, and then now once again the name of the function needs to be explained. Otherwise, Betty documentation will tell you that there is no explanation for the function. So print underscore alphabet is the entry point of our code. Once again, that function takes no argument, void. So it means no argument is supposed to be supplied into this function. Alright, so we're going to use our while loop. We start by saying, we start by initializing. So I would say char c. Char c here tells me that my c is a character. So my character is represented by a string a. Okay, so while c is less than or equal to z, now why am I including the equal to? I'm including the equal to because I want to print all of the alphabets in lower cases, including z. So that's why I have less than or equal to the string z. So my underscore put char will then print a, b, c, d as long as this loop remains valid. Do not forget to increment, otherwise you're going to get an endless while loop. So that's this C++ here is incremented that after running the first iteration, increments char c by 1, which will make a to become b, then run the while loop again. So we'll continue to run until this condition that we have set for the while loop becomes false, then the while loop will get exited. It's also important that you put your new line so that when the while loop runs once, it adds a new line, it runs a second time, adds a new line, it runs a third time, adds a new line. Exactly what you want the while loop to do. Once again, you :wq to save and quit. Do not compile, but at this point you can git add, git commit, and git push your code, and then you can run your check. So basically that's what you need to do across all of the task. At this point, let me go quickly to let me go to the task 9 and give an explanation of that task. Okay, so for your task 9, you're expected to write a function that prints the 9 times table starting with 0. Now this is the format that we are expecting. So for the 0 times table, you should have 0 all through the first time. You should have the 1 times table followed, the 2 times follows, the 3 times follows, and then you have your 9 times. So you should have 0 multiplied by 0, and then 1 multiplied by 9 all across board till you have 9 multiplied by 9, and that gives you 81. So you should have the 9 times table ranging from 9 by 9. That is from 0 times 9 to 9 times 9 across. Okay, so what we need to do is, once again, I'll copy the file name. I already have that in my sandbox, so I'll just show you what it looks like. Okay, so we'll start with the for loop. First, we initialize, or we declare 3 variables as integers. We declare the variable a to be an integer, the variable b to be an integer, and the variable c to also be an integer. So for a equals 0 and for a less than or equal to 9, and then we increment. Take note that for the for loop, we would always initialize, state our condition, and then increment. So for as long as we want the for loop to run between the ranges of 0 to 9, of a from 0 to 9, incrementing by 1. Also, we want b to also run such that b increments also from 0 to 9. And thereafter, we have the c, which is the product of a and b, which will give us the output that we want. So take, for example, for a equals to 0 and b equals to 0, we'll have a multiplied by 0, which will be 1. We can, if we increment, if I move to the next increment for a, that will be 1. I can then have 1 multiplied by 0, which will still give me 0. So my c is here. Now, if the value of c less than 10 is equivalent to 0, for instance, where I have 0 multiplied by 0 and I get 0, if 0 divided by 10 is equivalent to 0, then this body of code should be run. That is, if this is true, then the next if statement will check if b is equal to 0. If b is equivalent to 0, it would add a character called 0. But if b is not equivalent to 0, it's going to add a space. Okay, so for example here, when b is not equal to 0, we get a space. The next thing we do now is, if b is less than 9, add a comma. Okay, so we'll have a space and we'll also have a comma. We'll have a space, we'll also have a comma. Next, the next part of the code, let's move on to the next part of the code. Alright, so moving on, if c less than 10 is not equivalent to 0 this time around, what do? We're going to put char the value of c divided by 10 plus 0, and then we're also going to add the value of c modulo 10 plus 0 will then be printed. If b is less than 9, we'll add a comma and a space. So this would run the multiplication table for us. And don't forget that for us to, after every for loop, we need to add a new line, so that the for loop can, after running for all the iterations for 0, can then move on to the next line for the next iteration for 1. So basically that's what this multiplication table is all about. Once again, :WQ to quit, and then do not forget to git add, commit, and push your code at this point. Okay, so I'll take one of the advanced tasks. This advanced task looks similar to the one we just did earlier. It's a multiplication table of any number provided. It's going to start with 0, and the number must be greater than 15 or less than 0, and then you should print anything provided. Okay, so now we would be doing the let's look at the last advanced task. The last advanced task is to write a program that finds and print the first 98 Fibonacci numbers, starting with 1 and 2, followed by a new line. The numbers should be separated by a comma, followed by a space. You're not allowed to use standard libraries. You're not allowed to use any other library. You can't use GMP. You're not allowed to use long, malloc, pointers, arrays, tables, or structures. You're not allowed to add code any Fibonacci number except for 1 and 2. Okay, so once again, I already have that file. I'll just display the file for you guys to see and then explain it. So once again, the description of my the name of the function is num_length, and the description is provided here that says returns the length of string. Alright, so for this particular one, we won't be using our header file because it's an advanced task and there is no requirements that suggest that we have to use the header file main.h. So once again, I include my standard IO library. The function name is num_length, so I have to provide a description. Now this particular function is supposed to take an argument called num, so I have to explain what the num stands for. That's why you have @num here representing operand number, and it's supposed to return number of digits. So once again, I would set a variable called length. It's an integer and it's going to be initialized to 0. Now if not num, return 1, and while num, now after running, if num isn't provided, just return 1, and then we have while num is num less than 10. So this is like a mini function that we're having. Now what this mini function is supposed to do is just to help us to provide the length of the Fibonacci number we're trying to write. Okay, so we'll move on now to the actual body of the code. We have our int main, which is void, that is no argument. We'll start by providing some variables. First, we start with f1 as 1, f2 as 2, tmp not defined, mx, which is the maximum number, we have the value, f1o, which is 0, f2o, which is 0, tmpo, which is 0. We have a short, then we have these ones are unassigned longs, then these ones are short integers, I for 1, which is initialized as zeros. So for the value for I less than or equal to 9, so we're going to run this iteration continuously. What we're trying to do is, as usual, we know what Fibonacci number involves. If we have Fibonacci number 1, 1, 1, 1, and plus 1 gives us 2, so the next Fibonacci number will be 1, 2, 1. So we're trying to add up the Fibonacci numbers till we get all of the available numbers up to the first 98 Fibonacci numbers. That's why we have less than or equal to 98. So we initialize our OS as num_length, which is remember that we have a function here called num_length that is supposed to take an argument, which is going to be an integer. So we've provided the mx as the num_length, -1, then minus num_length f1, which is given to us here as 1. So also, while f1o is greater than 0 and the initial OS is greater than 0, it's going to print I, which is 1. Thereafter, we will have our OS to be minus, that is to be reduced. So we'll continue to reduce our initial OS. Then we print the long number, or the unassigned long number, which is indicated as our f1. So the TMP we did not declare earlier on can be obtained by using f1 plus f2 divided by mode mx. Our TMP 0 will be f10 plus f1 naught plus f2 0 plus f1 plus f2 divided by the maximum number. So we have our f1 to be equal to f2 this time around, and our f1 0 to be equal to f2 0, and our f2 to be equal to TMP, and then our f2 0 to be TMP 0. So if these conditions, then we say if I is not equal to 98, print a comma and a space, else give us a new line, and then we increment our I. So this relationship here is just a C program, a C code that helps us to increment or to do an incremental sum between our Fibonacci numbers in order to obtain the next one. Once again, we quit our code with colon WQ. Remember that you do not need to compile. All you need to do is git add, git commit, and git push. Alright, that'll be all for this video at this point. Do give a thumbs up to this video if you found it very useful. Do not forget to also subscribe. See you next time.